everyone. My name is Sophie Ruehr, and I'm a second-year PhD candidate at UC Berkeley. Today, I'm excited to talk to you a bit about my research regarding seeing photosynthesis in real time to study the global carbon cycle. So as you may know, plants are natural climate change mitigators, meaning that as they grow, they take carbon dioxide out of the atmosphere and thereby slow down climate change. In order to do this, they need access to water. And my research is focusing on how different types of water sources, for example, soil moisture, which is kind of near the surface, and deeper groundwater affect plants' abilities to grow and sequester carbon. How do I actually study the carbon cycle? Well, plants do this kind of crazy thing, which is that they glow. So sunlight comes into a plant and it's absorbed by the plant's tissues. Some of that energy is directed to doing photosynthesis and fixing carbon. Some of it is dissipated as heat, some of it just decays. And a tiny, tiny fraction of that energy is actually re-emitted as light at longer wavelengths. And that's that tiny slice of the pie chart there in the light green. This process is called solar-induced fluorescence, and it's a pretty new phenomenon that we're able to study with advances in hyperspectral imagery. And it's been shown that solar-induced fluorescence is a good proxy of photosynthesis, meaning we can leverage this measurement to study rates of carbon cycling across the world. Recently, I've been able to work with a really exciting new instrument that's able to measure photosynthesis across a landscape in real time. And I'm showing just some preliminary results of some field research we did last semester. On the left, you'll see just a picture I took on my iPhone of the scene. And the right is the product of the imager, which is able to capture photosynthesis rates across the scene. So the lighter colors in green and yellow are showing higher rates of photosynthesis, and the darker blue is showing kind of lower rates of photosynthesis. What's really exciting about this is you can actually see different rates of carbon cycling between different blades of grass and different areas on this landscape. So it's a really exciting new approach to studying carbon cycling at the site scale. We're planning to deploy this instrument at Point Reyes National Seashore this semester and continue taking images like this one to study how changes in soil moisture over the course of the growing season affect plants' ability to perform photosynthesis. Another thing that's really exciting about solar-induced fluorescence is that there have been sensors that can detect this plant glowing from space. There are a ton of satellites that are constantly orbiting the planet and observing changes on the Earth's surface over time. And some of those sensors can actually pick up this signal, this tiny signal of photosynthesis arising from plants. Recently, I've been working with these data sets to try to understand how photosynthesis relies on deeper water sources like groundwater, deeper than 1 meter below the surface. And this is just some preliminary results of my research showing areas in which plants are dependent on groundwater in the continental US. And you'll notice that a lot of the Western United States is showing some stronger groundwater dependency. And I would expect that because these are kind of more arid regions where plants might have to grow deeper roots in order to access water throughout the growing season, even when it's dry and drought conditions are on the surface. So this work is really exciting, and it's been so much fun to start doing this research over the past year and a half. And I look forward to continuing it into the future. I'd like to thank you all for listening, and also for the ARCS fellowship that has supported me the past 3 semesters. It's been such a privilege to focus on my research and really get invested in this field since I started at UC Berkeley. Feel free to write me a note if you'd like to learn more or talk about any of this research. And I look forward to meeting some of you at the symposium.